Gerze power plant is planned to be located on the Black Sea coast, 20 kilometers south of Sinop city center and 9 kilometers north of Gerze province, and to be taken into operation in 2014. Gerze power plant, with an installed capacity of 1,200 megawatts, will generate 7,500 gigawatt hours electricity annually, meeting 3% of electricity demand of Turkey. Gerze power plant will be based on supercritical steam technology. It is the leading clean coal technology which is becoming the system of choice for new commercial pulverized coal-fired plants worldwide. With this latest technology introduced recently to Turkey, Gerze power plant will be a modern, environmentally friendly power plant operating at standards which will not lead to any negative effect on natural life. Gerze power plant will generate electricity using high calorific value, low ash content, imported coal. The advantage of burning imported coal with supercritical steam technology is twofold. First, supercritical power plants operate at higher temperatures and pressures and are 35% more efficient than today's fleet of coal-fired plants. That is, they would use 35% less coal for the same power generation and emit 35% less. Secondly, utilization of imported coal instead of low calorific value coal further decreases the coal consumption and hence emissions. As a result, Gerze power plants will operate at lower emission levels than those of the European Union standards. The coal will be delivered from countries such as Russia, South Africa and Colombia via ships to the unloading jetty. It will then be transferred from the unloading jetty via cranes to an enclosed conveyor belt system and finally to the coal stockpile. From the coal stockpile, coal is transferred to intermediate bunkers via enclosed conveyor belts to minimize dust emissions and then supplied to coal mills. Dust suppression in the coal stockpile will be carried out by water sprinkling system. Coal is ground in hot air medium inside the coal mills and fed to the burners located on the boiler walls. Heat released by combustion is transferred to water walls through which demineralized water flows. The water is completely evaporated in the water walls and converted to supercritical steam in the superheaters. Supercritical steam is then sent to the turbine, where internal energy of high pressure and temperature steam is transferred to mechanical energy, which means rotation of the shaft. This mechanical energy is then converted to electrical energy via the generator. Electrical energy is then transferred to the transformer, where its voltage is increased. It is then supplied to the grid through the Boyabat and Bafra substations. Low pressure and temperature steam coming out of the turbine is sent to the condenser, where it is cooled by seawater, and the condensate is recycled to the boiler. Cooling water from the sea is returned back to the sea without being exposed to any treatment by a deep water discharge system. Deep water discharge system with its diffusers are designed to discharge the cooling water without disturbing the ecological system, in compliance with the requirements of environmental regulations. The plant is equipped with continuously working flue gas cleaning system comprising denitrification, desulfurization and dedusting units. Regarding denitrification system, the latest technology introduced to Turkey recently will be utilized. That is, nitrification content of the flue gas is reduced by 3 consecutive stages. The low nitrification burners, overfire air and selective catalytic reduction process on the path of the flue gas before the air preheater. Electrostatic precipitators with an efficiency of over 99% will be used to remove particulate matter from the flue gas. Dedusted flue gas enters the desulfurization unit operating with limestone gypsum wet flue gas desulfurization process, which has removal efficiencies over 98%. This process uses ground limestone reagent to react with sulfur dioxide from the flue gas, producing a gypsum byproduct, which is widely used in the construction industry and in concrete mixtures. Having gone through all the flue gas cleaning systems, the clean gas leaves the stack at emission levels lower than those of European Union directives. The stack gas emissions will be measured and recorded online with continuous emission monitoring system. Fly ash separated from the flue gas in electrostatic precipitators is pneumatically conveyed to fly ash silos. This byproduct will then be available for shipment to cement industry to be used in the production of blended Portland cement and concrete. The slag, which is the bottom product of the steam generator, is planned to be landfilled according to the related regulations, and the landfill will be afforested. Utilization of seawater for cooling is another environmental benefit of this project, which preserves underground water resources of the area. All fresh water requirements of Gerze power plant, such as demineralized water for boiler, firefighting, and service water and potable water, will be provided from desalinated seawater. The control of the plant will be executed by a distributed control system, which will fulfill all functional requirements and special tasks requested by the application. All safety and protection functions for plant components and assemblies will be fully automatic. The performance of Gerze power plant will be monitored continuously within the scope of environmental monitoring and management program. The company's official headquarters will be in the province of Gerze. During construction period, up to 2,500 people, and during the regular operation period, 600 people will be employed. This will create job opportunities and hence directly or indirectly contribute to the economy of the region. Priority will be given to local manpower. Support will be provided for the training of the younger generation in the energy sector. Gerze Power Plant is a modern project respectful to both human beings and the environment and is an entity of Anadolu Group.